I want to just give a super short introduction to who we are in case you haven't heard of us before. We're Evolve Lab, basically a computational design, BIM consulting, BIM management type firm. Kind of our motto is flex, inform, build, operate. So helping architects, engineers, contractors, and owners improve their BIM process. So that's kind of who we are and what we're about. Some of the services that we offer are BIM assessments, BIM implementation, BIM management, training, support, computational design, form rationalization, model authoring, and data authoring. So if you ever need any help with any of those, we'd be really stoked to help you guys out with some of those efforts. But that's enough about us. I want to go ahead and make sure that we get into why you guys are here, which is going to be talking about Grasshopper and Revit. So our learning objectives today are going to be gaining a greater understanding of parametric building modeling, learning how to prep data in Grasshopper for proper pushing of information into Revit, acquiring knowledge of how to prep Revit to be an optimal receiver of information, and then finally we'll learn how adaptive components play a large part in receiving information for the building information model. All right. So just a quick introduction. I know there's different people with different skills, and some people are really, really good at Grasshopper. Some people are really, really good at Revit. Most people, to be honest, aren't good at both. There are a handful of people in the United States and in the world that are good at both of those things. And then trying to integrate the two is really what we want to push for. So just a quick introduction to Grasshopper. Grasshopper is a tool for designers and engineers who are exploring new shapes using generative algorithms. Grasshopper is a graphical algorithm editor tightly integrated with Rhino's 3D modeling tools. Unlike RhinoScript, you don't have to know code. You just have to know how to use the nodes and the components, hook them up to create some really awesome geometry. So it's a lot more intuitive with these type of tools. What is Revit? If you don't know what Revit is a 4D BIM capable tool. It assists in tracking various stages in a building life cycle from concepts to facilities management. And so it's primarily used as a production or a documentation tool. And there's this huge gap between the design side and the production side. Usually people are either designing and modeling in SketchUp or Rhino, and then the production team comes on board, and then they're having to completely remodel the entire project. And so the purpose of this webinar is kind of to show you how to bridge the gap. And there's a couple different tools out there. Probably in the last couple years, these have really taken a lot of momentum. There's Chameleon, Geometry Gem, Cases Open NURBS utility, Hummingbird, and Lyrebird. And basically, these are the different tools that help integrate between Grasshopper and Revit. What we're really going to be looking at is Hummingbird. I've used a handful of these tools before. So far, my favorite is Hummingbird. The reason I like Hummingbird is because rather than just taking a mass object in Rhino and creating a mass object in Revit, which a lot of these tools do, you can use Hummingbird to actually push geometry from Rhino to Revit as systems. So you can push floors, you can push grids, you can push beams, you can push storefront. So it allows you to utilize the systems within Revit rather than just pushing a mass object from Rhino to Revit, creating another mass object in a sense. So basically the process for Hummingbird is you take Rhino and Grasshopper information, and what it does is it uses the DLL library. And what it does is it creates a CSV file, comma separated value file, and from that, Revit accesses that to understand where to put the information. We're not going to get too technical on this. You'll kind of see once we start using the tools how to do that. All right, so we're going to go ahead and dive in. I'm going to start opening up Rhino. And I'll close Grasshopper just so, or I'll minimize it, just so if you want to access Grasshopper, you have to download it from the internet, but you'll type in Grasshopper and it'll actually launch Grasshopper. I'm not going to do that right now just because I have a couple files open for the purposes of this presentation. But you'll launch Grasshopper, all right? And so basically Rhino over here on the right is our modeling software. And so it's going to be allow us to model geometric information, but it's just static geometry. It's not parametric. And so what we're going to do is we're going to use this add-in Grasshopper to make the information in Rhino parametric. So a pretty cool little utility that they had developed. If you're not familiar with Grasshopper, it's kind of similar to a lot of other programs you use, whether it's any of the Microsoft products or Revit. They have a ribbon system. And so in here, you'll have these various tools. So if you click on the ribbon, you can go to parameters, and you can hit the little drop down. So you can drop in a point if you wanted to. In here, they have all different types of geometry, whether it be a curve, a box, a plane, a surface. You can drop these in here. Now, what these tools do specifically on this portion right here is they're able to actually grab geometry from Rhino that you're actually able to utilize within your Grasshopper script. As you go across here, you have other operations like math, additions, multiplications, divisions, things like that. So just as an example, if I put in this addition here, and I can just put in a number. If you double click on the canvas, that'll allow you to create components here. And you could actually put in numbers to add these two objects together. Just real quick, I'll show you guys that so you can get an idea. You can also use number sliders. And so if you double click on the canvas, and if you start typing in any number, this is probably one of my favorite shortcuts. You can type in, say, 15, and then you have a number slider. And then the other one that's really important that you'll be using a lot in Grasshopper is the panel. And if you've used Dynamo at all, it's kind of like the watch utility. And so again, I'll double click here and I'll say panel, and it brings up a panel. And basically what I'm able to do is to see what's going on behind the scenes. So what I'm going to do is I'm just going to take this component, and you can see that I have 15 because I have my number slider here, and as I pull or push that, you can see the number updating on the panel. I'm just going to go ahead and copy and paste another one of these and put that in there. And you can see that I'm actually starting to get this addition. Now this is just a super simple example, but really the point of this is to show that Grasshopper and Rhino combined is just as much a building information software as Revit is. So I actually have information. I'm modeling, and I'm also accessing data, which is your building information. So just to kind of show that. So really cool little shortcuts here. Just by double clicking, just to reiterate, you can start typing anything that you think you want to do. So like maybe a circle, circle will come up. And so it's really easy to kind of start just typing information rather than having this really high learning curve. If you know what you want to draw or know what you want to model, just double click on the canvas and you can start building your own parametric shapes. Okay. So that you can either double click on the canvas or go through the ribbon up here to start creating these different objects. I'm not going to go through all of these because it'd be a pretty exhaustive presentation as far as Grasshopper. There's some great resources online that I would point you to. But again, the purpose of this is just to kind of introduce you to the parametric modeling and then the integration with Revit. So we're going to start really starting to dive into that. All right, so first off, let's go ahead and just create a point. What I'm going to do is I'm going to double click my canvas because it's just more efficient. And if you type in point, you can either put in a point right here, or if I want to say construct an XYZ point, you can type in construct. And there's this construct point. You can see it has XYZ. And I want you to look over here that I already have a point now in my model. Okay, it's already starting to represent what I have going on over here in Grasshopper. It's all live. And then what I'm going to do is I'm going to go ahead and double click my canvas again for a slider, and I'll type in 15, and I'll hook this up to the Z component just to kind of show. Now what I want you to know is the XYZ coordinates. If you've used AutoCAD or Revit, any of those tools, you should be familiar with the Xyz Coordinate System. So if I put in 15 to Z, notice the point updates. And right now I'll flex this, so I'm going up and down, and so it's going up to different numerical designations that I'm specifying in Grasshopper. All right, so I'm already starting to interact parametrically over here with my geometry on the right. Pretty simple stuff, right? All right, so what I want to do now is, if you're familiar with like an array or a series, I'm going to show you kind of how you can start seeing these points replicated over here in Rhino. All right, so what I'm going to use is something that's called a graph mapper as well. So if I type in graph, I can get my graph mapper, and I also want my series. Okay, and I'll show you what we're going to do with this graph mapper here in just a second. All right, so I'm going to take my series and I'm going to hook it up for my point. And you can see right here, I'm starting to get some information replicated. So it's actually offsetting in the z direction. So I have 10 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And then what I can do is if I put this in here, it's actually going to go both directions. So it's going in the y direction and in the z direction. You see that? All right. What I'm going to do is I'm going to start using what's called a sine curve. And so if you grab these graph mappers, you can do a right click and say graph types. And they have all these different types that you can do. You can do a linear graph, Perlin graph. The one I use most common is a sine graph. And what you want to do is start thinking about how big your geometry is going to be. Just for simplicity, I'm going to make it 100. And so in the x direction, I want to say my max is going to be 100. And in the y direction, I'm going to say 100. And this is really just saying x and y for this graph, okay? And you'll really see how this starts working here in just a second. And I'm going to disconnect both of these. Just wanted to show you those for example. And what I'm going to do is I'm going to hook this series up. Okay. And what I want to do now is I want to offset these in the z direction, but I also want to offset them in the x. So remember when I was doing it in both, it was going in both directions. That's what I want to try to do right now. Okay. Now with this series here, let's talk about this just for a second before we get too far. The series, you have this start, you have a step, and you have a count. The start, we're going to leave at 0 for this example. You can grab the number slider and copy paste those just to repurpose them. I'm going to hook this into the number. And what I want you to note is right here where the top of my graph is going to be the top of this point. And what it is it's 10 times 10, which is 100. So I have 10, a distance of 10, and then I have a count of 10. So between every one of these points is a distance of 10, and then I have 10 to count, okay? So you can see as I'm pushing this up, it's updating in my graph mapper. And what's really cool now, as you start to flex this, I'll pull this, you can start seeing the points interacting over here parametrically on the side, all right? So this is kind of how you can start modifying things parametrically in Rhino and Grasshopper. All right, well, let's keep on rolling with this because there's some really cool stuff that we can do. All right, next I'm going to go ahead and, again, you can select your components and you can copy paste them. And what I want to do is I want to create basically 3 of these, and I'll show you why in just a second. You can see right now I have 2, and I'm going to create 1 more. Copy paste this one. And basically what I'm trying to do is kind of build this facade system. Okay, so I'm pulling this down. I'll have this in the middle. I'm going to put this up at the top. Okay, and so I have these 3 independent graphs. And what I can do is I can control them independently, but since they're all hooked up to the same series, if I add a count, they add together. You see that? you can use the number slider. You can also double click in here, type 10, green checkbox to accept. So I still have 10 points. All right. Okay, what I want to do now is I want to offset this top one and this bottom one by a distance. And the reason I say a distance and not a specific distance is when you're working in Grasshopper, in parametric modeling, you're thinking a little differently. You're thinking of rules and constraints rather than a fixed object. Like maybe if you're working in SketchUp, you're like, no, I want it to be a 10-foot wall. Or if you're in Revit, it's a 15-foot wall. Well, in here, you want to try to think of rules and a distance as far as constraints. And so what I'm going to do is I want to offset this top one and this bottom one so we can get some kind of definition here in the y-axis. So you can see here's y, y, and y. And so what I'm going to do is type in 15 here. And I'm going to just push this one out. And you see it jump. Okay, so I'm parametrically moving that one. But what I can do is I can use this. I could either put in an independent one right here. I could create another one, hook this up, move it out independently as well. Or you can actually take both of them and hook them up together. So I have this is plugged into both the top and the bottom. So if I move either of these, they move together. Okay. Next, what I'm going to do is I'm going to put in a line. And what I want to do is put in a polyline. So again, I'm going to double click on my canvas. I'll put in a polyline. And you can see how I get a polyline, okay? But I don't want a polyline on just this top one. I could, copy paste this down and create a polyline, but I actually want it to be for all of these. So another tool that you're going to use a lot is going to be the Intertwine. And basically what this does is it combines data. And so what I'm going to do is grab this Intertwine, and I'm actually going to hook this one up to there, hook this one up to here, and hook this bottom one up. And then what I'm going to do is hook it into my polyline and watch what happens. You can see now I get this information for all three of them, okay? But actually I don't even want this. What I want to do is I want to put a line to here to here to here, all right? So I'm going to show you another tool that you'll use quite often, which is called flip matrix. And basically what flip matrix does is it makes rows columns and columns rows. And so again, if you double click in your canvas and you say flip matrix, watch what happens. I'm going to plug this in and I'm going to replace what was there before. You see that? So I'm actually getting these lines, and it changed it from a row to a column. It flips the way the data is organized, all right? So I'm going to go ahead and move this in here, try to keep it a little clean. All right, and now just to kind of show here, you can start seeing how these lines are interacting, and this is where it really starts to get interesting. So you can see as I update this, it's updating the lines, it's updating the points, and just in a series of 10-15 minutes, we've developed this pretty cool facade system that don't even ask me to try to do this in SketchUp or some other software, but it's actually I'm able to create multiple design iterations with these components here. Okay. All right. We're going to keep on trucking here. I'm going to increase my count just a little bit, just to give some more excitement to this system. And I want you to note too is if I change this the step, they get closer together. Okay. We can push this out a little bit. All right. This is looking cool. All right. Next, what I'm going to do is I'm going to put in a extrusion. And what I'm going to do is extrude these components in the X direction. So I'm going to double click and type in X. And then you can see already that I'm starting to get some geometric information in here. It's not just lines. I'm going to double click. I can put in a number. And you can see that I'm starting to get some really good geometry here. All right. And then what I want to do is I'm going to offset or create some geometry in the other direction as well, as in the Y, because right now this is just a flat plane. There's probably some better methods you could do too. You could probably create a closed box component that would snap to these, but just for the simplicity of, or for the purpose of showing you some really simple Grasshopper techniques, I'm going to show you that you can copy paste this again, and you can actually do this now in the Y direction. So I'm going to pull this one over here. I'm going to replace this X with a Y. Okay, I'm going to say I want to create extrusion, and we're going to say Y. And then this could be represented as some tube steel for a rain screen, something like that. But you can see I'm actually able to now parametrically drive that. Okay, really cool facade system going on here. And I can update this. It's updating all of my geometric information. Okay. And so what this allows you to do is to create multiple design iterations. Just in a few minutes here, in a pretty simple script, we have this pretty complex rain screen system. I'll show you another tool that you'll use quite often is this bake component. And so you can say objects that you want to bake. And if you double click in here, you can actually create a button. And I'll hook this up and I'll say bake. And now what I actually have is actual 3D geometry within Rhino. So I still have my parametric geometry, but I actually have now this static geometry in Rhino. And so the reason I'm showing you this is that you could do that, and then you could modify this to something else, bake it, grab that, pull it over. And so this allows you to create multiple design iterations of this rain screen very, very, very fast. Okay, you could just crank out, quite a few of these just over lunch or whenever. All right, so that's how you can create some of this parametric geometric information in Rhino. Let's start looking at now if I want to push this into Revit. Okay, I'm going to take this out just for simplicity's sake, and let's pull this back down. Get some more interesting geometry, because imagine if you had to model this in Revit, right? All right, so let's talk about the utilities for Hummingbird. Hummingbird uses this add-in right here. It's going to be called Extra. I don't know why they didn't just call it Hummingbird, but in here it's called Extra. And what I'm going to do is it's going to allow you to pick from different objects that you're used to in Revit. So whether it's beams or floors, and we're going to show some of these here in just a little bit. Excuse me. So what I want to do is I actually want to use the adaptive component for this. And I'll show you why in just a second. All right, so this is going to be an adaptive component in Revit. And basically it's going to be a 1, 2, 3 click. All right, so it's asking me, where are the points at? Well, it's not this extrusion. It's going to be these points back here. And I'll show you, you can see as I click, you see the points highlight. These are the important points to push through. So what I'm going to do is I'm going to grab these points from here, and I'm going to put them into the points component. Okay, this is this node right here is what takes the information from Grasshopper and creates that CSV file we were talking about earlier, so you can access it with Revit. All right. Next, I'm going to I need to tell it which family and which type to create. So just so I make sure that I grab it just right, I'm going to go back to Revit. And I do this quite often because it's very literal and it needs to make sure that it knows exactly what it is. For this example, I'm going to use this 3-point line adaptive. So if you just copy that, and what I'm going to do is I'm going to put it in my panel, and I can double click in here and Control V. There it is. That's what it's called. And I'll hook that up to the family. That's the name. The type is going to be the same. So if it's a different type, you'll need a new panel. But for this one, I know it's exactly the same. So I can use these for both of those. It wants to know the path. And so in here, we have to specify the path. I have it in this location. Of course, yours is going to be unique, so be aware of that. So it did that because I copy pasted from this other one. I want to make sure I grab this. Exactly, copy, paste. All right, so there's the path. Okay, and then it's going to be, what do you want to call this thing? Let's call it 3.4 webinar. Okay. And then the last one we need, there's some other ones we won't use for this push, but the last one we need is to tell it when to write it. So again, I'm going to use that button tool, the same one we used for the bake. And I'll hook that up. And you'll notice that the component went from that orange color to gray. That means that you have enough components hooked up to make this thing operate. All right, so what I'm going to do is I'm going to push this. Okay, and it doesn't look like it did much, but it actually went and pushed this component into this location. I'm going to push it again just to be sure. But if I go to here, and let's go to the View tab. Gotta love this new Windows 8. We'll go to List. All right, and then we should have, if we sort, well, let's do details based on date. We have this CSV file that it created, that 3.4 webinar. All right. What I'm going to do now is I'm going to go to Revit, and I want to show you the adaptive component that we're going to be using. All right, so in here, I have this 3-point adaptive component, just to kind of show you how these things work. Again, a lot of people know Grasshopper, a lot of people know Revit. They don't know both together, so I want you guys to know both, because this is really important. So I'm going to create a line, and I'm going to utilize this 3D snapping. Okay, and so it's just going to be a pick, pick, pick. What I'm trying to replicate is what we have going on in Rhino. So we'll pick, pick, pick. All right. And so what I'm going to do is I'm going to take these points, and I'm going to say make adaptive. And you can see I get this 1, 2, 3. What it does is it allows you to have these objects flex and the line update. All right. So this is how these work. All right. So let's go ahead and get back to Revit, and we'll push this. So using the model builder, I'm going to say create elements from file. This is accessing the CSV, and I'm going to say 3.4 webinar, right? And I need to tell it which one I want it to use. Okay. I'm going to say process. You can see it updating down here. And there it is. All right. It doesn't look real exciting with lines here. Okay, so we're going to switch it up a bit. But I wanted you to see it populate. Okay, so I'll take that out. And what I'm going to do now is I'm going to actually use an adaptive component that I created earlier. And it's a little more, it has actually some geometric information in it. So I actually have this rectangular kind of tube to represent that geometry. And so if I push this, you can see it updating. All right, so that's what that is. Let's close that. And what I want to do now is I want to tell it to use that instead. So I'm going to say use this guy. What I'm going to Control C. And so I'm going to tell it, you got to tell it which family and type to use. I'll put that one in there. And I'll say push. I'll go to Revit, the Hummingbird model builder, create elements from file, and I'm going to say 3-point for webinar. This time we're going to be using the 3-point adaptive, and we'll say process. And you can see that it actually created this geometric shape that we had in Rhino. Okay, so this is how you can start mitigating these data drops and pushing the information from Grasshopper over to Revit. All right, pretty cool stuff. All right, so that's that. Let's go ahead and look at some other ones that we can do. I know that we have some structural engineers represented too, which I'm totally stoked about. So I want to make sure that we show some applications for that as well. So I have this grid and beam push. This is one that I created beforehand just for the sake of time here. Something you have to get used to is I always want to do the shift middle mouse button for rotating. That's what it is in Revit. In Rhino, it's a right click. So something to get used to. All right, so what I have here, again, I'm using the series component and a collection of sliders. And what I've done is I've taken this series, put it into a point. I've moved it up 100 feet just so it's at the 100, the 0, 0, 100 feet in Revit. I've assigned a polar array to it, and then I've flipped the matrix so it works correctly. And I could probably show you this in just a minute. So what I want to do is kind of show you that, I have this, imagine this is maybe like a vehicular canopy or something like that. And so I can change the angle of this to be more or less. I can change the count. Can change the grid length. Okay, and I can change where it starts and stops. Okay. And this is where the start and stopping would be important with this particular script. With the other one, we wanted that at 0, but you can see kind of how you get a difference here, whether depending on where we start and stop it. All right. All right. So what I want you to notice too is this points. This one is really important. In here, what we want to do, I just noticed that I lost the video. I don't know if you guys care to look at me the whole time, but I'll have that up there. All right. So what we want to do is pay attention to these points right here. And so what they're doing, I'll make it can I make it a little smaller? If I make it bigger this way. You can see that it's counting 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Well, when I push this into Revit, I don't want it to place a grid like this. You could with your radial grids, you could want it to do that, but for this one I want to show these kind of grids going in this linear direction. And so what I want to do is I want it to be a click, 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 click. And so something you really got to get used to when you're starting to work with this method is how to interact with the data and to get it to show appropriately. And so what this flip is doing is it's actually creating those, changing the rows to columns and columns to rows like we talked about before. So now it's going to be a click, 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 all right? And so what I'm going to do is I'm going to push this information over into Revit. What I want to do first, maybe, what I'm going to do is I'm going to unhook the beams. I say disconnect this one just for this example first so you can see the grids update. And let's get this a little more dense. We'll add some more, something like that. And what I'm going to do is go ahead and hit my button. Okay. Let's just make sure it's called, okay, so it's called grid push. We'll go to Revit. Let me go ahead and delete this for now. And go to the floor plan. And I'll go to my model builder. I'm going to say create elements from file, and I'm going to grab the grid push that we just created. I'll say process. And did you see it? Updates right here. So I just updated the grids. All right. What I want to do now is I'm going to now push the beams. All right. And again, you got to know the family and the type name in Revit. Okay, so I'm going to do this. I'll unhook this one. And then I'm going to push this one. Say model builder, create elements from file. I'm going to say beam push, process. And you can see it placed these beams. Let's go to 3D view. Okay, those are giant for this little canopy. But you can specify the type and the size that you want. Okay. So pretty cool. So this is for structural engineers in the room. And so again, the reason it knows which component to grab is because I've specified the family and the type name here in Rhino. Okay, finally I want to show you that if you hook both of these up, you can actually push both at the same time. Okay. And in here, I actually don't believe I have a way to push them both at the same time. In Revit, but I would do this, and I could say push the grids, and then I can say push the beams, and it would push those, okay? So that's how you can actually start interacting with some of the structural information within Revit from Grasshopper. So integrating those two into Revit. All right. Okay, so just in summary here, so far we've looked at pushing the adaptive components, showing how those flex. We push some structural information. Let's go ahead and take a look at the some systems for architecture. In Grasshopper, similar to other programs, if you do a Control Tab, you can go between different windows. And I want to point something out too with this example. Grasshopper always kind of gets this rap for building. You're able to design these unbuildable forms, and some of that's true. I mean, you can design some pretty complicated things using computational design. But here's a really simple example of here. If I just had like a simple office building, all right. And what I'm going to do is I'm going to change the number of floors. Okay, you can, if you wanted to, and just do a very simple office building like this, you can. You don't have to create these super complicated geometric forms. You can just create an office building. I can change floor to floor heights easily. And you might be asking, like, why would I mean, I could just model that up simple. Well, I mean, you can actually start getting into some of the data as far as square foot. So programmatically, you can start saying, for each floor, this is my square feet. I'm at 4,997 square feet per floor. And so you can start thinking about that as you're updating your building. We increase a floor, a couple floors. This data is being updated constantly, and then here's the total square feet for the whole building. So this is, a way that it's advantageous to be able to just model super simple stuff parametrically. It doesn't have to be a crazy, twisty tower. With that said, let's create a crazy twisty tower. All right. So in here, I have this rotate component, and everybody loves the twisted towers. We always do the twisted towers. This is getting a little hamburgery squished. So I'm going to do is change some of this. It's a little bit better shape. Okay. So I can change the radius. Probably need to increase my floor to floor height. Let's do that right there. Okay. And so basically what I'm doing is I'm just going, a difference between a rectangle versus a polygon that I'm able to rotate, okay? And so in here, I can change the number of segments. So right now I have 5 sides, 1, 2, 3, 4, 5. I can change this, to 3 sides, 4 sides, if it suits your fancy. So let's do 5. What I'm going to do is I'm going to push this into Revit. And again, so I push this button, and what I have over to the right is all the same components that we had before. So you can push families, floors. This is the one we're using right now. You can push the adaptive components, which was the example we had before. Loft forms, rooms, and areas. These are all, Revit systems. It's the reason I love this hummingbird so much. But so for this one, I'm going to go ahead and push the floors. And actually, I need to change the location of where this one's being pushed. So Control C. I'll say OK. All right, let me push that again. All right, so I'll go back to Revit. Go to a 3D view. I'll delete this. Go to my hummingbird. Create elements from file. I'm going to do the floor push. Say process. Look at that. Okay, we'll zoom out a little bit so you can see it when it populates. Floor push, process, do. All right, now these are actually Revit system floors. It's not just a dumb three-dimensional mass, if I grab this thing and I say edit boundary, you know, it's a real Revit floor in here. Okay, you can do whatever you want with these now in Revit world. So that's how you can actually push a floor. These ones are a little harder. What I've done with these guys is I've actually am pushing these with an adaptive component, and just to kind of show how this is going to work, let me go to my, I think I have this one set up. I apologize if I don't. I had it set up earlier. Adaptive component, put it in the right location. Okay. What I'm going to do, just so you can see this and it doesn't take a super long time, I'm going to change the number of floors to 2. Okay, just something like this. I'm going to go ahead and push it. We'll go back to Revit. And what I want to do is use the adaptive curtain panel one. That was the one that I just created in Grasshopper, and I'll say process. And you can see what it's doing is it's actually placing this thing all the way around, just exactly similar to what we had in the Grasshopper file. So I mean, takes a little bit of time, but imagine, you know, when you start trying to develop some of this complex geometry, trying to manually model this stuff or try to figure out is just, you know, a lot of brain damage. You know, this allows you to model it parametrically in Grasshopper and then push the data into Revit. And so it's placing these adaptive components. It's doing a click, 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 4 clicks for this adaptive component based on where the points were in the Grasshopper script. And so you can see it walking all the way around. And this is the reason I only did one floor. If you wanted to, you could cancel. I'm just going to let it finish here because it's almost done. You can see how it's actually starting to, you can see the twisting exactly how it was in Rhino. This is pretty cool. Okay, we'll close that. And you can see that now I have this component that is native within the Revit environment. Okay, it's actually pushed every single one of those from here over. Okay. All right. Well, we're getting pretty close to the end here. Let's see if maybe there's a couple other little tips and tricks I can talk to you guys about. In here, again, I want to just point out that these are all part of the extra utility in here. I'm going to take questions in just a minute, so if you guys have any questions, you can go ahead and start speaking into the or typing it into the webinar. But these are the different components you can use. You can use beams, columns, floors, walls. Walls are a little trickier with this push, I found. It is doable, but you really have to be really specific on how you format your data. You have to do that anyways. The adaptive components we did, you can push families. If you wanted to say, I want a task chair in every room in my building, you could go ahead and push the families. You can actually push loft forms, mass families, and topography. The other thing we talked about was the grids. We didn't do levels or lines, but those are a couple other ones you can do, as well as rooms and areas. The reason I didn't touch on these ones is it's a little finicky as far as being able to get the data to push over to Revit. Definitely still doable, but it's a lot more brain damage. And you know, this one I wanted to just kind of give you guys a super quick introduction to some of these tools and not totally overwhelm you. But these are the different types of systems that you can actually use using this hummingbird utility. All right. Another thing I want to give kudos to is the Lunchbox tool utility created from Nathan Miller. That one is what I use to divide the surface in here for this project. I don't want to use that tool without giving a good shout out to Mr. Nate. So thanks, Nathan, for developing this. It's really slick for dividing surfaces. There's also some other really great utilities out there that I don't have in here for this webinar, but you can actually create planar panels so that you don't have this twisty glass, which is, you know, essentially not buildable. You can actually create planar objects, and maybe I'll show that in the next webinar. The next one I'm planning on doing, for those that are interested, I'm also going to do a Dynamo. this is Grasshopper pushed into Revit. Some people may be asking, well, why don't you just use Dynamo? Well, one of the reasons I don't use Dynamo right now is because Dynamo doesn't have these graph mappers yet. I think they might be in the works, but you can't use a graph mapper in Dynamo. They do allow you to do some sine curves using some of their utilities, but you can't use the graph mapper. So that's one of the reasons I'm still dabbling in Grasshopper and pushing it into Revit for those that are interested. But yeah, we'll do a Dynamo one. Something I wanted to mention too that I think that I glossed over on this example was the points. You want to make sure that your points are formatted appropriately when you're pushing into Revit. Again, this is going to be the point utility. And so I can say points, show me the points. All right. And I'll say, what size do you want those points? Show this real quick and then we'll jump into questions. Okay. You can see here, these are the points that are getting pushed into Revit. Maybe I can hide. You can click on these. You can click on your middle mouse button and hide these. Okay, and you can see what it's doing is going 0 through 20. What I did again is I used this flip utility, and that makes it go 0, 1, 2, 0, 1, 2, 0, 1, 2. That's really important for those adaptive components. And I missed that for the first one, so I'll make sure you guys know about that for this example. All right. So look forward to a Dynamo one coming up. Probably do that next month.